Welcome to For Science Salah Lotfy channel. Today we're diving into the fascinating world of electromagnetic fields. Electromagnetic fields are everywhere, from the radio waves that bring music to your ears to the X-rays that let doctors see inside your body. We'll also explore groundbreaking research by Professor Dr. Noaman El-Tahawy, Professor of Radiobiology, and Dr. Amr Abd El-Hady. Their study investigates how VitaminE and Silymarin can protect rat testes from the effects of electromagnetic fields. Stay tuned as we unravel the science behind electromagnetic fields and discover the innovative research making waves in this field. Don't forget to like, share, and subscribe to For Science Salah Lotfy channel for more exciting scientific insights. Imagine a world where you can't see, touch, or hear one of the most powerful forces in your life. This force connects your phone calls, warms your food, and even helps doctors peer inside your body. This force is the electromagnetic field. Electromagnetic fields, or EMFs, are all around us, yet most of us rarely think about them. From the moment you wake up and check your phone to the time you watch TV before bed, EMFs play a crucial role. Without them, our modern conveniences would cease to exist. We'll explore the electromagnetic spectrum, which is a range of all types of EMFs, from the very low-frequency radio waves to the incredibly high-frequency gamma rays. By the end, you'll have a newfound appreciation for this unseen power that surrounds us. They are a testament to the incredible advancements in science and technology that shape our world. What exactly are electromagnetic fields? In simple terms, they are invisible fields produced by electrically charged objects. When we talk about EMFs, we're referring to areas of energy that result from this electrical charge. They are a fundamental force of nature, just like gravity or magnetism, and they have two main components: electric fields and magnetic fields. Electric fields are created by electric charges. Whenever you have a positive or negative charge, it generates an electric field around it. Magnetic fields, on the other hand, arise from moving electric charges, specifically electric currents. When an electric current flows through a wire, it generates a magnetic field around it. Together, these two types of fields form what we know as electromagnetic fields. This interplay is at the heart of many technologies we rely on every day. Electromagnetic fields are produced whenever electrical energy is generated, transmitted, or consumed. This process involves the movement of electric charges, which creates both electric and magnetic fields. When an electric charge moves, it creates a magnetic field perpendicular to its direction of motion. For instance, in a simple circuit with a battery and a wire, the movement of electrons through the wire generates a magnetic field around the wire. The strength and direction of the magnetic field depend on the current's intensity and direction. Similarly, an electric field is produced by stationary charges. If you have a charged object, like a balloon rubbed on your hair, it creates an electric field around it. In more complex systems, such as antennas used for broadcasting, the situation becomes even more intricate. An alternating current flows through the antenna, generating changing electric and magnetic fields. Understanding how these fields are generated and interact helps us harness their power for various applications. The electromagnetic spectrum is the range of all types of electromagnetic radiation. It is divided into different sections based on frequency and wavelength. The spectrum spans from very low-frequency radio waves to extremely high-frequency gamma rays. Each type of wave in the spectrum has unique properties and uses. Radio waves have the longest wavelengths and the lowest frequencies. They are used for communication, such as broadcasting radio and television signals. Microwaves, which have shorter wavelengths, are used in radar technology and for cooking food. Moving up the spectrum, we encounter infrared radiation, which is emitted by warm objects and is used in night vision devices and remote controls. Visible light is a small portion of the spectrum that our eyes can detect. Beyond visible light, we find ultraviolet radiation, X-rays, and gamma rays, each with its own set of characteristics and applications. Section 5. Radio waves, the backbone of communication. Radio waves are a pivotal part of our daily lives. They are the backbone of modern communication systems, enabling us to connect over vast distances. Radio waves have the lowest frequency and the longest wavelength in the electromagnetic spectrum. This makes them well suited for transmitting signals over long distances without much interference. One of the most common uses of radio waves is in broadcasting. Radio stations transmit audio signals via radio waves, which can be received by radios in homes and cars. Television broadcasting also relies on radio waves to deliver audio and visual content to viewers. In addition to broadcasting, radio waves are essential for mobile communication. Systems like GPS use radio signals from satellites to determine the location of a receiver on Earth. Section 6. Microwaves. Not just for popcorn. When we think of microwaves, we often think of the kitchen appliance used to heat food quickly. However, microwaves have a range of applications beyond cooking. These waves have shorter wavelengths and higher frequencies than radio waves, placing them in a unique position within the electromagnetic spectrum. One of the most important uses of microwaves is in telecommunications. They are used to transmit data over long distances through satellite communications. Microwaves can travel through the Earth's atmosphere without much interference, making them ideal for sending signals to and from satellites orbiting the planet. This technology underpins global communication networks, including internet and television services. Microwaves are also used in radar technology. Radar uses microwave signals to detect objects and determine their distance, speed, and other characteristics. Section 7. Infrared and visible light. Seeing beyond the ordinary. Infrared radiation and visible light occupy adjacent positions on the electromagnetic spectrum. Infrared radiation has longer wavelengths than visible light and is emitted by warm objects. This type of radiation is invisible to the naked eye, but it can be detected using special equipment, such as infrared cameras. One of the most common uses of infrared technology is in night vision devices. These devices detect infrared radiation and convert it into an image we can see, allowing us to see in the dark. Infrared technology is also used in remote controls for televisions and other electronic devices. Visible light, on the other hand, is the portion of the spectrum that our eyes can detect. It includes all the colors that we see, from red to violet. Visible light is essential for our perception of the world around us. Section 8. Ultraviolet, X-rays, and gamma rays beyond our sight. Ultraviolet or UV radiation, X-rays, and gamma rays are types of electromagnetic waves with very high frequencies and short wavelengths. While they are invisible to the human eye, their effects are significant and far-reaching. Ultraviolet radiation is primarily known for its effects from the sun. It can cause sunburns and increase the risk of skin cancer. However, UV radiation also has beneficial uses. It is employed in sterilization and disinfection processes because it can kill bacteria and viruses. X-rays have even higher frequencies and are well known for their use in medical imaging. Gamma rays with the highest frequencies and shortest wavelengths are produced by nuclear reactions and radioactive decay. They are used in cancer treatment to target and destroy cancer cells. Section 9. Benefits of electromagnetic fields in modern life. Electromagnetic fields have brought numerous benefits to modern life, revolutionizing various fields and improving our quality of living. One of the most significant areas impacted by EMFs is communication. The advent of radio waves and microwaves has made it possible to transmit information over long distances quickly and efficiently. This has led to the development of radio, television, mobile phones, and the internet, transforming how we connect and share information globally. In the field of medicine, EMFs have enabled groundbreaking diagnostic and treatment technologies. X-rays and magnetic resonance imaging, or MRI, use electromagnetic radiation to create detailed images of the body's interior, aiding in the diagnosis of various medical conditions. Additionally, radiation therapy uses high-frequency electromagnetic waves like gamma rays to treat cancer, targeting and destroying malignant cells. In our daily lives, EMFs are ubiquitous and essential. Household appliances such as microwaves, refrigerators, and washing machines rely on electromagnetic technology to function. Section 10. Potential harms and the need for regulation. While electromagnetic fields offer numerous benefits, they also pose potential risks that must be managed carefully. Prolonged exposure to certain types of electromagnetic radiation can have harmful effects on human health. For instance, excessive UV radiation from the sun can lead to skin cancer. Similarly, overexposure to X-rays and gamma rays can damage tissues and increase the risk of cancer. One area of concern is the impact of EMFs from everyday devices like mobile phones and Wi-Fi routers. While these devices operate at low frequencies and are generally considered safe, there is ongoing research into their long-term health effects. To mitigate these risks, regulations and guidelines have been established by health and safety organizations. Public awareness and education are also crucial in managing the potential harms of EMFs. Section 11. Conclusion: the unseen pillar of our technological world. In conclusion, electromagnetic fields are an unseen yet integral part of our technological world. From the moment we wake up to the time we go to bed, EMFs influence our lives in countless ways. They facilitate communication, enhance medical diagnostics and treatments, and bring convenience to our daily activities. Understanding what electromagnetic fields are and how they work helps us appreciate their significance and the role they play in modern society. The electromagnetic spectrum, with its diverse range of waves from radio waves to gamma rays, encompasses a variety of applications. Each type of wave has unique properties that make it suitable for different uses, whether in broadcasting, cooking, medical imaging, or scientific research. The benefits of these technologies are vast, improving our quality of life and expanding our capabilities. By respecting and harnessing their power responsibly, we can continue to thrive in an increasingly interconnected world.
Welcome to For Science Salah Lotfy channel. Today, we are excited to introduce a groundbreaking research study titled The Possible Protective Effect of VitaminE and/or Silymarin on Rat Testes, Exposed to 950 MHz Electromagnetic Field. This groundbreaking study was meticulously conducted by two highly distinguished researchers, each bringing a wealth of knowledge and expertise to the table. First, we have the esteemed Professor Dr. Noaman Abd El-Tahawy. He is a renowned professor of radiobiology from the Radiation Biology Department at the National Center for Radiation Research and Technology, which is part of the Egyptian Atomic Energy Authority, located in Cairo, Egypt. His extensive research in radiobiology has significantly contributed to our understanding of radiation effects on biological systems. Secondly, we have the dedicated Dr. Amr Abd El-Hady. He is a prominent faculty member from the Faculty of Applied Medical Sciences at Misr University for Science and Technology, situated in the vibrant city of 6th of October, Cairo, Egypt. His work in applied medical sciences has been pivotal in advancing medical research and education, making significant strides in the field. Their groundbreaking research has been published in the prestigious Journal of Bioscience and Applied Research, a leading publication in the field. You can find this comprehensive study in the 2015 edition, specifically in Volume 1, Issue 3. The detailed findings are meticulously documented, spanning pages 97 to 111. For more information and to access the full text of the study, you can visit the journal's official website at www.jabsar.com. The website offers a wealth of resources and additional research articles for those interested in further exploration. This study investigates the potential protective effects of vitamin E, a powerful antioxidant known for its role in protecting cells from damage. Additionally, we explore the benefits of Silymarin, an extract from the milk thistle plant, on the testes of rats exposed to 950 MHz electromagnetic fields. With the increasing exposure to electromagnetic fields from everyday devices, such as mobile phones, Wi-Fi routers, and other electronic gadgets, this research is crucial for understanding how we can mitigate possible health risks associated with prolonged exposure. In the upcoming parts of our series, we will delve deeper into the methodology, results, and implications of this significant research. We will examine how the experiments were conducted, the data collected, and the conclusions drawn from this comprehensive study. Stay tuned as we uncover the potential health benefits of vitamin E and Silymarin, and how they might protect against the adverse effects of electromagnetic fields. Stay tuned for more insights from For Science Salah Lotfy channel. See you next time.
We live in a world saturated with invisible forces. Electromagnetic fields, or EMFs, are one such force. They are generated by everything from power lines to cell phones. These fields permeate our environment. We are constantly bathed in their energy. The long-term effects of this exposure are still being studied. However, there is growing concern about their impact on our health. The impact of EMFs on male fertility has been a subject of scientific debate for years. Some studies show a link between EMF exposure and decreased sperm quality. Others find no connection. This highlights the complexity of the issue. more research is needed. To understand the potential protective effects of antioxidants, El-Tahawy and El-Hady designed a meticulous experiment. They divided male albino rats into 5 distinct groups. Each group was subjected to a different set of conditions. This allowed the researchers to isolate the effects of EMFs and antioxidants. The first group served as the control group. These rats were not exposed to any EMFs or given any antioxidants. Their data served as the baseline for comparison. The second group was exposed to EMFs for a specific duration. This group helped the researchers understand the direct effects of EMFs on the rats' testes. The third group was pre-treated with vitamin E before being exposed to EMFs. The fourth group received pre-treatment with Silymarin, another potent antioxidant. These 2 groups allowed the researchers to assess the individual protective effects of each antioxidant. Finally, the 5th group received a combination of vitamin E and Silymarin before EMF exposure. This group aimed to determine if combining the antioxidants provided any synergistic protective effects. Antioxidants are the body's natural defense system against free radicals. These unstable molecules are a byproduct of normal metabolism. They are also generated in greater quantities when the body is exposed to environmental stressors like pollution, radiation, and potentially EMFs. Free radicals are highly reactive. They can damage cells, proteins, and DNA. This damage is known as oxidative stress. Vitamin E is a fat-soluble vitamin and a potent antioxidant. It is found in various foods, including nuts, seeds, and vegetable oils. Vitamin E works by donating an electron to free radicals. This neutralizes them and prevents them from causing further damage. Silymarin, on the other hand, is a natural extract from the milk thistle plant. It has been used for centuries in traditional medicine for its liver-protecting properties. Silymarin is a powerful antioxidant. It works by scavenging free radicals and boosting the body's own antioxidant defenses. Both vitamin E and Silymarin have shown promise in protecting against various diseases linked to oxidative stress. These include heart disease, cancer, and neurodegenerative disorders. Their potential role in mitigating EMF-induced damage made them ideal candidates for El-Tahawy and El-Hady's study. Section 5, Group 1, the baseline. A glimpse into normal rat physiology. The control group in El-Tahawy and El-Hady's experiment provided a crucial point of reference. These rats, not subjected to EMF radiation or given any antioxidant supplementation, showcased the normal physiological functioning of their testes. The researchers meticulously examined various parameters in this group. Testicular weight, a key indicator of testicular health, was carefully measured and recorded. Sperm count, a direct measure of male fertility, was assessed to establish a baseline level. Sperm motility, the ability of sperm to move properly towards an egg, was also analyzed as a crucial factor in successful fertilization. The data collected from this group provided a baseline. This baseline allowed the researchers to compare and contrast the effects of EMFs and the protective potential of antioxidants in the subsequent groups. By establishing a clear picture of normal testicular health, the control group played a vital role in the study's overall findings. The EMF exposed, observing the effects of electromagnetic radiation. The second group of rats faced the full brunt of EMF exposure. Researchers observed a significant decrease in testicular weight. The sperm count was significantly lower. A decline in sperm motility was also noted. These findings suggest potential detrimental effects of EMFs on male reproductive health. Section 7, Group 3, the protected, vitamin E and its potential shield. El-Tahawy and El-Hady studied vitamin E's protective effects. Rats pre-treated with vitamin E showed less EMF damage. Their testicular weight was higher than the EMF-exposed group. Sperm count and motility improved with vitamin E. Vitamin E shows promise against EMF-induced damage. Section 8, Group 4, the shielded. Silymarin's role in cellular defense. In parallel with investigating vitamin E, El-Tahawy and El-Hady also explored the protective capabilities of Silymarin. The fourth group of rats received pre-treatment with Silymarin before being exposed to the same EMF conditions as the previous groups. This allowed the researchers to isolate and analyze the specific effects of Silymarin on EMF-induced testicular damage. The findings from this group were equally promising. Similar to the vitamin E group, the Silymarin-treated rats showed less severe testicular damage compared to the EMF-exposed group. Their testicular weight was higher, indicating a protective effect against EMF-induced shrinkage. The sperm count in the Silymarin group also presented a positive trend. While not reaching the levels of the control group, it was significantly higher than the count observed in the EMF-exposed group. This finding further supported the potential of Silymarin to protect against EMF-induced reductions in sperm production. Sperm motility in the Silymarin group echoed the positive trend. The sperm in this group showed better motility compared to the EMF-exposed group, suggesting improved sperm function and, consequently, better chances of fertilization. Section 9, Group 5. The combined force, synergistic protection against EMF damage. The fifth and final group of rats in El-Tahawy and El-Hady's experiment received a combined pre-treatment of both VitaminE and Silymarin before EMF exposure. This group was designed to investigate whether combining these two antioxidants would yield any synergistic protective effects, potentially amplifying their individual benefits. The results from this group were particularly compelling. The rats receiving both VitaminE and Silymarin showed the most significant protection against EMF-induced damage. Their testicular weight was closest to that of the control group, indicating robust protection against shrinkage. Moreover, their sperm count was significantly higher than that of any other EMF-exposed group, even surpassing the groups treated with either VitaminE or Silymarin alone. This finding strongly suggested a synergistic effect of the two antioxidants, boosting sperm production beyond what either could achieve individually. The sperm motility in this group further solidified the findings. The sperm of rats treated with both antioxidants demonstrated the highest motility among the EMF-exposed groups, indicating the healthiest and most functional sperm. These results highlighted the remarkable potential of combining antioxidants for maximizing protection against EMF-induced damage. Section 10. A call to action, implications for a world awash in EMFs. The findings from El-Tahawy and El-Hady's study have significant implications for public health, particularly in our increasingly technology-dependent world. With the proliferation of electronic devices from smartphones and laptops to Wi-Fi routers and Bluetooth devices, our exposure to EMFs is constantly increasing. While more research is needed to fully understand the long-term effects of this exposure on humans, this study raises important concerns and highlights the need for protective strategies. The study's results strongly suggest that EMF exposure can negatively impact male reproductive health, potentially contributing to declining sperm counts and motility observed globally. This finding is particularly concerning considering the increasing prevalence of infertility worldwide. However, the study also offers a beacon of hope. The protective effects of antioxidants like VitaminE and Silymarin, especially when combined, suggest a potential avenue for mitigating these risks. Incorporating these antioxidants into our diets or through supplementation could offer a degree of protection against EMF-induced damage. This research underscores the importance of a balanced diet rich in fruits, vegetables, and other antioxidant-rich foods. Section 11. The future of protection, unlocking the full potential of antioxidants. While El-Tahawy and El-Hady's study provides compelling evidence for the protective effects of antioxidants against EMF damage in rats, further research is crucial to translate these findings to humans. Future studies should focus on replicating these results in human subjects, exploring different dosages and combinations of antioxidants, and investigating their long-term effects. Understanding the precise mechanisms by which EMFs affect human cells and how antioxidants counteract this damage is paramount. Moreover, research should explore other potential protective strategies against EMF damage, such as developing EMF shielding materials for electronic devices or implementing guidelines for safe distances and durations of exposure. Public awareness campaigns are essential to educate people about the potential risks of EMF exposure and empower them to make informed decisions about their technology use. This includes promoting healthy habits like limiting screen time, maintaining a safe distance from electronic devices, and consuming a balanced diet rich in antioxidants. By investing in research and promoting responsible technology use, we can harness the benefits of our digital world while mitigating the potential risks to our health and well-being.
We live in a world increasingly saturated with electromagnetic fields, or EMFs. These fields are all around us, generated by the technology we rely on every day. These invisible forces, generated by everything from power lines to cell phones, are omnipresent in our daily lives. They have become an inescapable part of modern life, influencing how we communicate, work, and even relax. While EMFs have undoubtedly revolutionized our world, concerns about their potential health effects continue to grow. People are becoming more aware and worried about the unseen risks. Numerous studies suggest that prolonged exposure to EMFs could harm our bodies, with male reproductive health a particular concern. This has led to increased scientific scrutiny. This is where the importance of scientific research comes in. Researchers are working tirelessly to understand the full impact of EMFs on our health. By understanding how EMFs affect biological systems, we can develop strategies to mitigate potential risks. This knowledge is crucial for creating safer environments. The quest to uncover the protective effects of VitaminE and Silymarin against EMF-induced testicular damage in rats is a crucial step in this direction. These studies are vital for future health guidelines. This research holds the potential to provide valuable insights into safeguarding public health in our increasingly electrified world. It could lead to new recommendations and protective measures for everyone. Our bodies are constantly bombarded by free radicals, unstable molecules that can damage cells and DNA. These free radicals are produced naturally in our bodies, but their levels can be significantly increased by external factors such as pollution, radiation, and even certain lifestyle choices like smoking and poor diet. EMFs, or electromagnetic fields, are believed to exacerbate this oxidative stress, leading to a cascade of harmful effects. Prolonged exposure to EMFs can disrupt cellular function and contribute to various health issues, including increased oxidative damage. This is where antioxidants like VitaminE and Silymarin come into play. These compounds help neutralize free radicals, thereby reducing oxidative stress and its associated damage. VitaminE, a powerful antioxidant found in nuts and seeds, is known to scavenge free radicals and protect cell membranes from damage. It also supports immune function and skin health, making it a vital nutrient for overall well-being. Silymarin, extracted from the milk thistle plant, boasts a long history of use in traditional medicine for its liver-protecting properties. It has been used for centuries to treat liver disorders and improve liver function. It acts as an antioxidant and anti-inflammatory agent, shielding cells from oxidative stress. Silymarin also promotes cellular repair and regeneration, further enhancing its protective effects. This study aims to investigate whether these natural compounds can shield the testes from the damaging effects of EMFs. By understanding their protective mechanisms, we can develop better strategies to mitigate EMF-induced damage and improve reproductive health. In this scientific investigation, we employed a well-established animal model, the laboratory rat. Rats share a surprising degree of physiological similarity with humans, making them valuable subjects for biomedical research. Their reproductive systems in particular exhibit many parallels to our own, allowing us to extrapolate findings with cautious optimism. Using rats in a controlled laboratory setting allows us to isolate the specific effects of EMF exposure and the potential protective roles of VitaminE and Silymarin. This level of control is crucial for obtaining reliable and scientifically sound results. By studying the impact of EMFs on rat testes, we can gain valuable insights into the potential risks posed to human reproductive health. To mimic real-world EMF exposure, we subjected our rat subjects to a specific type of electromagnetic wave known as 900 Hz. This frequency is commonly used in mobile phone technology and Wi-Fi signals, making it a relevant exposure scenario for humans. The rats were exposed to these EMFs for a specific duration and intensity, carefully calibrated to simulate levels commonly encountered in everyday life. This controlled exposure allowed us to study the direct impact of EMFs on testicular tissue while minimizing the influence of other environmental factors. Section 5. The power of antioxidants, VitaminE and Silymarin in action. Our study investigated the potential protective effects of VitaminE and Silymarin against EMF-induced testicular damage. We aimed to understand how these antioxidants could mitigate the harmful impacts of electromagnetic fields. To achieve this, we divided our rat subjects into distinct groups, each receiving different treatments. This method ensured a comprehensive analysis of the antioxidants' effectiveness. One group of rats was exposed to 900 MHz EMFs without any protective treatment. This group served as our baseline for understanding the full impact of EMF exposure. Another group received vitamin E supplementation alongside EMF exposure. Vitamin E is known for its potent antioxidant properties. Similarly, a separate group received Silymarin supplementation in conjunction with EMF exposure. Silymarin, derived from milk thistle, is also a powerful antioxidant. A control group was not exposed to EMFs and did not receive any supplementation. This group helped us understand the natural state of the subjects without any external influences. This experimental design allowed us to isolate and compare the effects of EMF exposure with and without the protective interventions of vitamin E and Silymarin. The results provided valuable insights into the potential benefits of these antioxidants in combating EMF-induced damage. Section 6. A closer look unveiling the microscopic changes. To assess the impact of EMF exposure and the potential protective roles of vitamin E and Silymarin, we delved into the microscopic world of testicular tissue. Using sophisticated techniques like histopathological and histochemical analysis, we examined the cellular architecture and biochemical changes within the testes of our rat subjects. Histopathological analysis allowed us to visualize the structural integrity of the testes, looking for any signs of damage, such as cellular degeneration or inflammation. Histochemical techniques, on the other hand, enabled us to detect specific molecules and enzymes within the testicular tissue, providing insights into the biochemical processes affected by EMF exposure and antioxidant treatment. Section 7. Painting a clearer picture, analyzing the data. After meticulously collecting data from our histopathological and histochemical analyses, we embarked on the crucial task of data analysis. We employed robust statistical methods to identify any significant differences between the experimental groups. By comparing the degree of testicular damage, cellular changes, and biochemical alterations in each group, we aimed to determine whether vitamin E or Silymarin effectively mitigated the harmful effects of EMF exposure. This rigorous statistical analysis was essential for drawing meaningful conclusions from our findings. Section 8. The verdict: protection against EMF damage. Our findings revealed that exposure to 900 MHz electromagnetic waves led to noticeable damage in the testicular tissue of rats. This damage manifested as structural abnormalities, increased oxidative stress, and disruptions in normal cellular functions. These observations underscore the potential risks associated with prolonged EMF exposure, particularly for male reproductive health. However, the groups that received vitamin E or Silymarin supplementation alongside EMF exposure exhibited significantly less testicular damage. The antioxidants effectively countered the oxidative stress induced by EMFs, protecting the delicate cellular structures and functions within the testes. These results highlight the potential of vitamin E and Silymarin as protective agents against EMF-induced testicular damage. Section 9. Beyond the lab implications for human health. While our study focused on rats, the findings hold profound implications for human health. The increasing prevalence of EMFs in our environment necessitates a deeper understanding of their potential impact on our well-being, particularly for vulnerable populations like developing children and pregnant women. This research provides compelling evidence that vitamin E and Silymarin, readily available as dietary supplements, could offer a degree of protection against EMF-induced damage. However, it is crucial to emphasize that further research is needed to confirm these findings in humans and establish safe and effective dosage recommendations. Section 10. A call to action: protecting ourselves in a connected world. As we navigate an increasingly interconnected world, minimizing unnecessary EMF exposure is prudent. Simple measures like limiting screen time, maintaining a safe distance from electronic devices, and using hands-free options for mobile phones can significantly reduce our exposure levels. Incorporating antioxidant-rich foods into our diets, such as nuts, seeds, fruits, and vegetables, can bolster our body's natural defenses against oxidative stress. This, combined with a healthy lifestyle that includes regular exercise, stress management, and adequate sleep, can further enhance our resilience to potential EMF-induced harm. Section 11. The future of EMF research: unraveling the mysteries. This study represents a significant step forward in our understanding of EMFs and their potential impact on male reproductive health. However, the journey of scientific exploration is far from over. Further research is crucial to unravel the complex interplay between EMFs, oxidative stress, and cellular damage. Future investigations should explore the long-term effects of EMF exposure, the impact of different EMF frequencies and intensities, and the potential benefits of other antioxidant compounds. By continuing to illuminate the intricacies of EMF interactions with biological systems, we can pave the way for a safer and healthier future in our increasingly electrified. We are surrounded by electromagnetic fields, or EMFs, every single day. These are invisible forces generated by the electronic devices we use daily, often without a second thought. Our cell phones, laptops, Wi-Fi routers, and even microwave ovens emit EMFs, creating a web of electromagnetic activity around us. While these technologies have revolutionized our lives, making them more convenient and connected, concerns have been raised about the potential health effects of prolonged EMF exposure. One significant area of concern is the impact of EMFs on male reproductive health, particularly the testes, which are crucial for fertility. The testes are highly sensitive to environmental factors, and numerous studies have suggested that EMF exposure might impair testicular function and fertility, leading to potential reproductive issues. This is where the groundbreaking research of Professor Dr. Noaman El-Tahawy and Dr. Amr Abd El-Hady becomes particularly relevant. In 2015, these visionary scientists published a pivotal study in the Journal of Bioscience and applied research that shed light on the protective effects of VitaminE and Silymarin against EMF-induced testicular damage in rats, offering a glimmer of hope. Their findings have significant implications for understanding and mitigating the potential risks of EMF exposure on human health, paving the way for future research and protective measures. The testes are the primary male reproductive organs responsible for producing sperm and the hormone testosterone. These organs are very sensitive to external factors that can disrupt their normal function. One such factor is exposure to electromagnetic fields. Studies have shown that EMF exposure can cause various detrimental effects on the testes. These effects include reduced sperm count and motility, abnormal sperm morphology, hormonal imbalances, oxidative stress, and damage to testicular cells. These changes can ultimately lead to infertility and other reproductive health issues. Understanding the mechanisms by which EMFs induce testicular damage is crucial for developing strategies to protect male fertility. Antioxidants are our body's natural defenders against damage caused by harmful molecules called free radicals. VitaminE and Silymarin are two powerful antioxidants that have shown promise in protecting against EMF-induced damage. VitaminE is a fat-soluble vitamin that acts as a potent scavenger of free radicals, preventing them from damaging cells and tissues. It is found in various foods, including nuts, seeds, and vegetable oils. Silymarin, on the other hand, is a natural compound extracted from the milk thistle plant. It has strong antioxidant and anti-inflammatory properties, protecting the liver and other organs from damage. Both VitaminE and Silymarin have been extensively studied for their potential health benefits. Their ability to combat oxidative stress and inflammation makes them promising candidates for protecting the testes from EMF-induced damage. To investigate the protective effects of VitaminE and Silymarin, El-Tahawy and El-Hady meticulously divided laboratory rats into 5 distinct groups, each with a specific purpose. The first group, known as the control group, consisted of rats that were not exposed to EMFs and did not receive any treatment whatsoever. They served as the baseline for comparison, providing essential data to measure the effects of the treatments. The second group, referred to as the irradiated group, was exposed to EMFs for a specific duration to simulate the effects of prolonged exposure to electromagnetic fields. The third group, named the VitaminE group, received oral supplementation of vitamin E in addition to being exposed to EMFs to test the protective effects of the vitamin. The fourth group, called the Silymarin group, was similar to the vitamin E group, but these rats were exposed to EMFs and also received oral Silymarin supplementation, another potential protective agent. Finally, the fifth group, known as the combined treatment group, received both vitamin E and Silymarin supplementation along with EMF exposure to evaluate the combined protective effects of both substances. This meticulous grouping allowed the researchers to isolate the effects of EMF exposure and evaluate the individual and combined protective effects of vitamin E and Silymarin, providing a comprehensive understanding of their potential benefits. Section 5. Examining the control group, a picture of health. The control group, living a life free from electromagnetic field exposure and any treatment, provided a crucial point of reference. Their testes exhibited normal, healthy characteristics. This group served as a benchmark against which the researchers could compare the changes observed in the other groups. By observing the control group, the researchers established a clear understanding of what normal, healthy testicular tissue should look like. This baseline was essential for accurately assessing the impact of electromagnetic field exposure and the protective effects of the treatments in the other groups. Section 6. The impact of EMF changes in the irradiated group. The irradiated group, exposed to EMFs without any protective measures, presented a different picture. Their testicular tissues showed significant alterations compared to the control group. These changes, observed under a microscope, painted a clear picture of EMF-induced damage. The researchers observed a decrease in the number of sperm cells. This reduction in sperm count is a significant concern as it directly impacts fertility. Additionally, the sperm that remained showed reduced motility, meaning they were less able to swim effectively towards an egg for fertilization. The EMF exposure also led to structural changes in the testes. The seminiferous tubules, the site of sperm production, appeared disorganized and damaged. These observations confirmed the detrimental effects of EMFs on testicular health. Section 7. Vitamin E to the rescue, observing the protective effects. The group receiving vitamin E supplementation along with EMF exposure showcased the antioxidants' remarkable protective abilities. The researchers were keen to observe how vitamin E could counteract the oxidative stress caused by EMFs. Their testicular tissues, when compared to the irradiated group, showed significant improvements. The cells appeared healthier and more resilient, indicating a strong protective effect. These observations highlighted vitamin E's potential in mitigating the harmful effects of EMFs. The data clearly demonstrated a reduction in oxidative damage. The researchers observed a less pronounced decrease in sperm count and motility in the vitamin E group compared to the irradiated group. This was a crucial finding as it suggested that vitamin E could help maintain reproductive health. This suggested that vitamin E helped protect sperm cells from EMF-induced damage, preserving their quantity and quality. The antioxidant properties of vitamin E played a significant role in this protective mechanism. Furthermore, the structural integrity of the seminiferous tubules was better maintained in the vitamin E group. The tubules showed fewer signs of disorganization and damage. The tubules appeared more organized and the damage was less severe than in the irradiated group. This structural preservation is vital for overall testicular function. These findings indicated that vitamin E helped protect the structural integrity of the testes against EMF-induced oxidative stress. The study provided compelling evidence for the use of vitamin E as a protective agent in environments with high EMF exposure. Section 8. Silymarin's role, another shield against damage. The group treated with Silymarin presented a similar story of resilience against EMF-induced damage. The researchers observed significant improvements in testicular health in this group compared to the irradiated group, highlighting Silymarin's potential as a protective agent. Silymarin's antioxidant and anti-inflammatory properties shined through in the observations. The testicular tissue of the Silymarin group showed reduced oxidative stress markers compared to the irradiated group. This indicated that Silymarin effectively neutralized the harmful free radicals generated by EMF exposure. Moreover, the Silymarin group exhibited less severe structural damage in the testes. The seminiferous tubules appeared more organized and the overall architecture of the testes was better preserved. These findings suggested that Silymarin played a crucial role in protecting the structural integrity of the testes against EMF-induced damage. Section 9. The dynamic duo combined treatment and enhanced protection. The group that received both vitamin E and Silymarin supplementation demonstrated the most remarkable recovery. Their testicular tissues showed the most significant improvements compared to all other groups, highlighting the synergistic effects of these two antioxidants. The combination of vitamin E and Silymarin appeared to provide superior protection against EMF-induced damage. The researchers observed a near-normal sperm count and motility in this group, suggesting that the combined treatment effectively countered the detrimental effects of EMFs on sperm production and function. Furthermore, the testicular tissues of the combined treatment group exhibited the least amount of structural damage. The seminiferous tubules appeared healthy and well organized, indicating that the combined treatment effectively protected the structural integrity of the testes against EMF exposure.
For Science Salah Lotfy channel, Professor Dr. Salah Lotfy. Hello and welcome to For Science Salah Lotfy channel. Today, I would like to take a moment to express my heartfelt gratitude to two outstanding researchers who have made significant contributions to the field of radiation biology. Professor Dr. Salah Lotfy. First, I want to extend my heartfelt gratitude to Professor Dr. Noaman El-Tahawy, a distinguished and highly respected professor of radiobiology at the National Center for Radiation Research and Technology, Egyptian Atomic Energy Authority, located in the vibrant city of Cairo, Egypt. His contributions to the field are truly remarkable. His unparalleled expertise and unwavering dedication in the specialized field of radiation biology have been absolutely instrumental in significantly advancing our comprehensive understanding of the protective effects of antioxidants against the potentially harmful impacts of electromagnetic fields. His work continues to inspire and pave the way for future research and innovation in this critical area of study. Professor Dr. Salah Lotfy says, I also extend my sincere appreciation to Dr. Amr Abd El-Hady from the Faculty of Applied Medical Sciences, Misr University for Science and Technology, located in 6th of October, Cairo, Egypt. He continues, Dr. Abd El-Hady's research alongside Professor El-Tahawy has provided invaluable insights into how vitamin E and Silymarin can protect rat testes from the harmful effects of electromagnetic fields. Their collaborative work has opened new avenues in understanding the biological impacts of electromagnetic exposure, which is increasingly relevant in our technology-driven world. The dedication and meticulous approach of Dr. Abd El-Hady and his team have not only advanced scientific knowledge, but also paved the way for potential therapeutic applications. This research is a testament to the innovative spirit and academic excellence fostered at Misr University for Science and Technology. Professor Dr. Salah Lotfy highlights the significance of their recent research. Their comprehensive study, published in the prestigious Journal of Bioscience and Applied Research, is a testament to their relentless hard work, dedication, and innovative approach. It not only adds valuable knowledge to the scientific community, but also has far-reaching potential implications for improving public health outcomes. He adds, "We are truly honored to feature their groundbreaking work on our channel, recognizing the impact it could have on future research and public health initiatives." Professor Dr. Salah Lotfy concludes, "Thank you, Professor Dr. Noaman El-Tahawy and Dr. Amr Abd El-Hady, for your invaluable contributions to science. Your dedication and passion inspire us all. To our viewers, stay tuned for more insightful content here on For Science, Salah Lotfy channel. Until next time.